Okay, so today, like I said in the first session, what we're going to do is um, first we are going to take that extract parameter experiment we did before, and we will today do temperature test on it. And because we did in the morning, we saw some of the effects of temperature on some of the parameters. So we are going to look at it and see if it is what we claimed in the first session. And the second part, what we're going to do is we're going to today use Python to automate that extraction part. So there is a nice Python interface, which was written by Mike Perot, the person who wrote CPP Sim. So it's part of that. So what I'll do is I'll show you quickly how to read the data file, how to set up and read the data file, and and show you how to extract. I've already written the code for extracting the VT. I'll go through it one line by line just to kind of get you acquainted with Python. So if you have never seen Python, don't worry about it. I've already created a code, and what you can do is you can add a little bit more of it and just play around with it. You know, that's how I've never done a Python course or anything. That's how I just took a code and I just started playing around with it. I think that's the best way, at least for me, best way to kind of play around with it. I mean, at some point, you definitely want, if you're like a serious software engineer, you want to do some course, but just for script writing, you can just play around with it. Some example codes to get started. So that's what we'll do today. Okay. So and once you're done, then for some of the other parameters, and you can just play around with it, and I'll leave you guys free to play around with it. So I'll just introduce these two things, and then we can take it from there. Okay, first thing, I hope everyone has their terminal on. You CD into um, the JIT repo, the SI 2021-03-CMOS-VLSI, and just do a JIT um, space pull to update it. So I'm already up to date, so it's showing already up to date. But you should see a directory called lab 8 get pulled in the labs folder. So if you do, sorry, there's a labs folder. In that, there is a lab 8. I think this is the 8th lab. So you should see a folder pull up. Okay. And essentially there is a spice code in this, and there is a Python script in it. So, but we are not going to work in this area. We'll go back to our work area. Once you have done the JIT update, has just let me know once everyone is done their JIT update. Just raise your hand, those who have done the JIT update. That way I know. Yeah, just go to that directory and do a JIT update. I mean JIT space pull. Just keep your hands up so that way I know at least most of you are done. So go into that git repo and then do a git space pull. All our lab is dependent on that, so you have to pull that before we proceed. Okay, I'll assume everyone is done by now. So once you've done that, you've updated, like as I said, you should have that lab 8 folder in labs folder. So, but don't work there because that's kind of a read-only repo we have. You can't, you know, you may get overwritten next time you do a update. So you go back to your work directory. So for me, it is lab in your home directory. And then I think I already, so let me just delete this rm minus rf lab 8. Okay, so what you want to do is you want to copy that lab 8 directory to your to the workspace you are working. So in my case, it's lab in home directory, and I'm going to just copy the um, lab 8 directory here. So you can copy it by, so go to the directory you want to copy to. So in my case, you can see it's home Saroj lab. And then here you do CP and then tilde, that is basically saying you're starting from the home directory. And then /si, you can just type tab labs and lab 8. Sorry, you have to do CP space minus RF and then space dot. So CP space minus RF, then give the source file name, which is the entire directory. So SI, CMOS, VLSI, labs, lab 8. And then dot means it will copy with the same name, which is lab 8. Okay. So if you hit enter, you should have a lab 8 directory. And now you CD into that lab 8 directory. And like I said, you should see these two files, vgs-id-temp.sp, and there is a file called extract vt/kp.py. So one is obviously a spice netlist, another one is a Python file. So we'll start with the spice netlist first. But let me know if you all have this copied. I'll just wait for a few minutes for you guys to copy this.
Excuse me, sir.
Yes.
So there is some error coming in after copying.
What's the error?
It says missing destination file operand after the directory name.
Yeah, you have to give dot, right? I said you have to give the file name which you want the final destination name. So there is a dot after lab 8. So you have to space
Lab
dot.
space. Okay.
Yeah, dot means keep the same file name. You've been doing Linux now for 3 weeks. You guys shouldn't be asking this question, but it's okay. Go ahead and do that. Does everybody have the lab file copied now? Just raise your hand who has the file copied now. They have the lab
So
folder.
that symbol is not working here.
Which
Then before
symbol?
that, before that SI 2021 hyphen RF
Yeah,
CP hyphen RF.
that's tilde. That's tilde. Shift. That's on the right
Yes,
below
yes, sir.
escape.
Not
What's the
yes,
problem?
sir.
Yeah,
But
what's the problem?
not. It's not showing here. Means it's not displaying that.
Okay, just give the total path. So the tilde is basically for giving home whatever is your username. So you can give your home username. I told you, right, from that first class, that tilde is for your home. It's a shortcut for home. So you can just type $home there as well. You can type $home / SI, SI, or you can just give
Okay.
home, Saroj, in your case, whatever username, SI, either one will work. Okay, anybody stuck? Want me to wait till you copy the library? Okay. Yeah, just keep your hands raised. Once you're done, just unraise your hand, and once you're done, I'll proceed. Those who are in the process, just keep your hands raised. Once you're done, just so before you copy, you have to go to the repo, do a git space pull. That'll get you the lab directory, and then go ahead to wherever you're working. In my case, it is home /home /home Saroj lab. In your case, if it is different, go to that place and copy that directory lab 8, the whole directory.
Excuse me, sir. Hello.
Praveen, you have a question?
Yes, sir. Sorry to interrupt. What we need to do before Bitfull, sir? I have joined.
No. Git pull is the first thing you do. So you just go to the, that repo directory, SI21,
Okay.
and then just do a git space
Okay.
pull.
Okay.
Obviously, I'm up to date. It'll say already up to date. In your case, it'll pull the lab. And then
Okay.
you go to wherever your working directory. In my case, it's labs.
Okay.
And then do a CP minus RF from your home,
Okay.
SI21 labs, lab 8, and copy it to the place where you want to copy. Okay.
Okay. Okay, sir.
Once
Thank
you're
you.
done with that, then we'll start.
Okay.
Because I have some pre-written code already, just to kind of, avoid people writing a lot of stuff. Okay, Soumya and Brathiranjan, are you still stuck or you're done?
Yes, sir. Done, sir.
Okay, so you can, all right. So, okay, now once you're in this folder, like I said, you have 2 files. We'll start with the spice file and we'll do some temperature experiment. We'll try to see the effects we have claimed in the morning. some of the effects we claimed in the morning. And for that, you can either, I'm going to open it in VI. People who are still uncomfortable with VI, they can, there is a program called LeafPad here. I haven't used it, but seems fine. So you can use LeafPad where, and by the way, so if you can start LeafPad either from the start menu here, and I think it's in Office, I believe. No, not Office. Graphics, Debian applications, accessories. Yeah, accessories. You see there is LeafPad here. So you can go here and do file open, start that. You can as well start from the command line as well, where you can just say LeafPad and then the file name. Sorry, got the wrong file here. LeafPad. What is it? VT. Now, what is the file name? VGS ID SP. And if you want to use this terminal after the LeafPad comes, you can end it with an ampersand sign. If you do that, then it will send this to the background, but it will still be working. So that way you can still use the shell. So if I do that, you'll see LeafPad come up. And now you can see there's no color coding because LeafPad doesn't know what a spice file is. So you can just edit. And this is a more like a notepad editor where you do cursor and you type whatever you want and so on. So if somebody is still uncomfortable with VI, they can use this. Okay. So I'll just go ahead and use Vim. So we'll use this for the editor, and you can open maybe 2 more tabs. So let's open just 1 more tab first, and let's name this tab netlist like we did before, and let's name this tab ngSpice. Okay, and we'll start ngSpice here like before. So type ngSpice and you should get ngSpice command here. Let's go back to the netlist and let's open the VGS ID. It's the same one as before. I just have one, but I have, you can see I put like 1 or 2 lines which says fix me. So that way, at least you do some writing to get acquainted with it. So let's go to the first one. So essentially we want the same thing like we did before. We want to set up the experiment in, basically we'll have an NMOS. Actually, let me write, so maybe do it here. So let me do this at the corner here. So we'll have a NMOS, source and ball grounded, and drain, a gate and drain connected together. And this is your VDS, right? So this is going to be M1, let's say. We'll name this as M1. And this node I've already, oh, actually, hold on a second. I have the current monitor too. So I'll just erase this.
Excuse me.
Yes?
Sir, can you go to the command window again?
Give me 1 second. So this is my VDS, which is already there. This is my VID1, which I've already instantiated. This is node D. This is node D1. And obviously this is ground 0. So now you can go ahead and instantiate M1, because like I said, I just deliberately removed it from here. So now you can go and instantiate this M1 over here with these node connections like we had before. Oh, who was it? Was it
Sir,
Suman?
yes.
Yeah, what do you want?
Please move to the command window again.
I don't have the command window anymore, but yeah, what do you want?
No, no, like, where did you get that code? I was asking that.
Once you copy did you copy the library lab 8?
Yes, sir. Sir, I have did till that leafpad 2 files. I have opened that, but after that, what to do?
So you have the code or not?
No, sir. Like after typing leafpad and I got 2 file names. In those 2 file names, I got the code in the notepad.
Do you have this? Do you have this or not? This library right now?
Yes, sir.
Lab 8.
Yes,
Okay,
sir.
do ALS. Do you have these 2 files?
Yes, sir.
Okay, open leafpad, VGS, this, and do ampersand. Or you can open, go from start here, and then go accessories, the leafpad, file, open, go to your home directory, go to labs folder, lab 8, and do VGS, and open from here as well. Either ways, whatever suits you, whatever you like, whatever is your modus operandi du jour, you do that. Got it? You got this code or not?
Yes, sir. I got that code.
So, okay, so now what do you want?
Sir, after that, what to do? I was asking.
I just, like as I said, I have removed that M1 instance. Instead of listening, you're just asking a lot of questions. So this is the same experiment we did before, right? We connected gate to drain and we added this ammeter and we gave a drain to source voltage. I have everything here like we did in the previous one. Let me go back to before I start overwriting this. Okay, what I want you guys to do now is instantiate that M1 with these connections, just like we had before. I basically just removed it deliberately so that you get some exercise, right? I mean, I got the code just to give you some. If I asked you to write the entire code, then we'll be here till 7, right? So I'm just
Yes.
telling you that I've removed something. I have a fix me on the lines where you want, and I've told you what to do in those lines. You just read those lines and instantiate it. I mean, write that code.
Okay, sir. Okay.
Okay, everyone has it now. Does anyone want me to wait? All right, I'll take that as a no. So I'll keep the name M1, and it is what the node connections. What is the order for the node connection? Drain, gate, source, bulk, right?
Yes.
So the drain should be what? The
D1.
node D1, gate should
D1.
be D1, source should be
0, 0.
0. Actually, I made a mistake in the thing. I don't want the bulk because I'm going to do gamma extraction also. So let me add that. So instead of connecting the bulk to 0, I'll connect it to another voltage source. And I already have that VBS, right? So that voltage source is already here, VSB. So bulk, I'm going to connect it to the node bulk B because that's what the voltage source is going to connect it to. Okay, then what? What should I do now?
Width and length should be specified.
What's that?
The W and L.
Before that?
SC-MOS and
Yeah, you need the model, right? It needs to know which model because it could be anything, right? So
yes.
SCMOS-N is what we have, what we are instantiating here from this .lib file, right? SCMOS-N, and then we can give WL. So we'll keep the WL. What did we have? 5, right? 5, and L equals to, I think, 5, 1. So we'll keep that, right? Oops. Okay, everyone got that? So save that, do a Shift W or Control S if you're on leaf pad. And let's go to the next one. I can erase this fix me line here. So that's fixed now. Let's go to the next fix me is this one. So here I want to add a DC sweep VDS from 0.1 volts to 2 volts, step of 0.01. Okay, quickly, somebody come online and guide me. What should I do? DC sweep.
So VDS.
What's the command? What should I start with?
Dot DC.
Dot DC
VDS
VDS
0
0.1
0.1 to
2
2
0.001.
0.001. So basically dot DC, which voltage you want to vary, which voltage source you want to vary, or current source, whatever it is, right? So that's the source name. And then start point, end point, step size, correct? Okay, so this is fixed. We can erase this. Okay, let's next go. What is the next one? So now I want to plot a root, square root of 2ID versus V of D. Okay, quickly, someone come online. Who was, who came online last time? Srishti, can you tell me what command should be? How about a low?
Plot
Yeah. Okay, Srishti, yeah, go ahead. Plot.
square root of 2ID.
Square root. Let's do it the way we did it. I don't.
Root.
So 2 times. You remember two times? Then how do I get the
ID
2
of
times? Yeah, but how, what
ID.
was the command for ID? It is the voltage source hashed branch, right? It's the branch, means it's the branch current. There are other ways to do it too. Let's stick with the one we did so that everyone is on board, right? And then we did to the power 0.5, right? So that,
Yes.
and then we did versus V of D,
V
which
of
is
D.
kind of assumed, but you can explicitly do that, right? Okay. All right. So we got all our commands. So let's just run this now. Let's go to the ngSpice window and then do source. What was the name? VGS tab. Okay, we got some plot. Okay, so looks like we have some plot. Seems like close to 0.5. This is the VT, and this is a slope. So we have already calculated this, so we're not going to do the calculation again. What we're interested now is to, so if you guys remember, right, this slope, so the intercept, right, sorry, 1 second. Let me change this color here. So this intercept here, this was our VT0 because VSB is 0. And then we calculated this slope, right? And this slope was equal to √2 times KP, because this is 2 times ID root over, right? This slope. So it's KP times, what is it? W over L, right? So in order to find KP, we took this slope times square and then L over W, and that's how we got KP, right? And then for gamma, we did another with VSB, some other values, got the same value and did gamma, right?
Yes, sir.
Okay, so, all right. So now what we are going to do is we are going to change the temperature, sweep the temperature and see. So what we predicted is this, and let's see if we get that. So you remember in the morning session, this is what we predicted. We said that as we make the temperature higher, because mu and VT and the intrinsic carrier concentration, the way they are changing with temperature, your current is going to become lower. That's because mu is getting lower, which means that the slope is getting smaller. So if the slope is getting smaller, then this will be, let's say this is TR, this will be T1, which is higher than TR. So T1 higher than TR. And then if I raise the temperature, it will be more, and so on. If I lower the temperature, then the mu increases, so it'll be more here. Like so, this is how. And we predicted that the subthreshold current. So we introduced subthreshold current in the morning. You remember it was because it's like a BJT effect because of the minority carriers, and the minority carriers of high temperature, they actually increase. So those current actually will start not drawn to scale here. Those current will actually increase, right? So this high temperature ones, and for the lower temperature ones, it will decrease. So that's so, and there is one point here where it'll be no variation. So this is like that sweet spot where if you bias this transistor, it'll magically just remain constant and the current won't vary, right? So this is what we predicted, and obviously, oh yeah, and it's from this graph, we also know that if this slope is increasing, if I extend this, then VT is also, so the original VT was here, let's say 0.5. Then as we raise the temperature, this slope is decreasing, which means that if I extend it, then it'll intercept at a lower point. That means VT is decreasing, right? VT is greater than, less than VT 0. So that's the other prediction we did, that VT should decrease. So let's change, sweep the temperature now and see if that's true. Let's quit this. Let's go back to our netlist window. And so for sweeping, so I want the same curves for different temperature right now. So who can tell me how to do, what should I do in my analysis to get that? I mean, obviously I
But
can do, yeah.
Instead of norm, we will use SS.
No, that's process. So that's a different process. You remember in the morning, right? You remember what the process means. Process is basically saying the fabrication house, each time they fabricate your chip, it can be a different number. Okay, your mu naught can be different, your VT can be different. But given a certain process, then if you change the temperature from -40 to 125 or 0 to 100 or whatever you're changing, the parameters will change on top of that. So they are two completely independent events. So either you change the process or you change the temperature, or both, but they are completely independent events. They're not related. Okay, so that's process. We'll do that later on. But I want to change this temperature. So what I did now is for 27 degrees centigrade, right? So dot temp is 27. So obviously I can change it here. So I can change it here, but I want to see relatively all the plots at the same time. So how do I sweep it? I want to sweep it along with the VDS. You remember how we swept the VSB when we did the gamma, when we wanted to calculate gamma, we swept VSB, right, on top of it. So we kind of nested it, right? Sorry, 1 second. So we can do the same nesting here, but instead of VSB or anything, we call it temp. So temp is a keyword in SPICE, which tells you that vary the temperature. And so let's vary the temperature from 0 to, let's say, 100 degrees centigrade, step size of 20 degrees. So let's, that'll give us like 5 curves. So this is a nested loop. So nested loop means for every temperature, so it will start the temperature at 0 degrees centigrade, and it will do the VDS sweep. Then it will go to 20 because the step size is 20. It'll do another sweep. Then it'll go to 40, do another sweep, 60, 80, and 100, and it'll have 5 plots. Okay. So everyone just add this to your DC analysis. So after your the VDS one, add temp 0, 100, 20. Just do that. I'll wait for a few seconds. Okay, so everyone has that, and once you write that, now you can do a source again. All of you have this curve.
Yes, sir.
Yeah, Praveen, got the curve?
Yes, sir.
Okay, good. Anyone working on it want me to wait? Raise your hand. Okay, good. Looks like everyone has uh, the output. Okay, so Spice, the inbuilt Spice plotter unfortunately doesn't have the legends, but just trust me on this one. This curve is your t equals to 0, and this curve is your t equals to 100. Okay, and you can do that by setting temp and checking it, but you should get this. Okay, now you can see that. So let's see mu first, right? Mu is what? Proportional to the slope, right? So t equals to 0 has a higher slope than t equals to 100. So obviously we know that then mu at 0 degrees centigrade is higher than mu at 100 degrees centigrade, right? So everyone, uh, and obviously if you have that, then if you're extending this for t equals to 100, so let's say t equals to 100, we get about 0.55 or something. And then if you are doing for t equals to, let me just zoom this in. So I'm just going to just zoom in this part here. Okay, so so if this is, so this, like I said, it is for t equals to 0 degrees C, and this curve is for t equals to 100, and obviously the next one is 20, 40, 60, and so on, right? So if I take this one, then the intercept is, let's say it's going to be whatever, 0.5, right? Or 0.55 or 52 for the t. If I take this one, since the slope is smaller, then this will intercept, I'm exaggerating it. We'll calculate it with our Python program, but for now, just assume. So VT, let's say at 0 degrees centigrade, let's say it's some 0.5 something, then VT at 100 is 0.45 or whatever it is. We'll calculate the exact ones when we do the Python program. For right now, just you can just see that from the slope, if I just extrapolate it, then obviously they're going to intercept at the higher temperature is going to intercept at a lower voltage. The lower temperature is going to intercept at a higher voltage. And we saw how this was coming because most of the component of the VT is coming from the work function and phi-f, and these two, the way, because it's a negative term in your VT term, so they tend to reduce. Okay, so just, and the mu, obviously it's to do with scattering, phonon scattering. So as the temperature increases, the phonon scattering increases, that's why mu decreases. Okay, and the subthreshold, let me just, actually I can just clear this. Let me zoom again. I mean, you can see that the lower temperature one goes below, higher temperature goes above. So if I just zoom in here, you can see that this is upside down now, right? Because you saw how they were crossing the line there. So this curve now is for t equals to 100. This curve is now for t equals to 0 degrees C. Okay. And like I said, it's just the absolute current is increasing. That doesn't mean the slope is increasing. And I'll show you the slope by doing the log plot, because as we predicted in the subthreshold equation that it is exponential, it looks like a BJT, but you might look in this curve here. If you look at the original curve here, you might see you can't make out, right? That's because just the absolute current is so small, you're not able to see that. Okay, so we'll do a log plot now. We'll take a log of this, and it'll be more clear once you do the log, because then it'll magnify this portion, and you can see the slope being higher right now. But everyone clear here? Everyone got this plot? Any questions on this one? So this is exactly, and you can see, oh yeah, then you can see that there is one point here where the current absolutely doesn't vary, and it's about, like, for this particular case is about 640 or what is it, 652 millivolts. Okay, so at 652 millivolts for this size, this corner, if you bias it, then you're going to get exactly what is it, 1.5 milliamp of current, and it will remain constant with respect to temperature. And like as we said in the morning, typically, in analog design, we need a temperature independent current all the time, but we actually don't use it because, to create a circuit to detect this point, and this will vary over process and voltages, not voltage, process. To create this, it's a lot more complex current. So there are other ways to do this instead. Okay. So everyone clear on this plot? Any questions?
Yes, Sati.
Okay, good. All right, now let's do, like as I said, in order to see the subthreshold part, because we said subthreshold increases exponentially, so the gain is much higher actually than saturation. So what we'll do is, instead of doing a linear plot, we'll do a log plot. Okay. So, and for log, the SPICE has a lot of mathematical function, and log is actually one of the functions. So what I'm going to do is, I can remove this fix. So just copy this line to another one, so that way we have this in case we want to use in the future. So copy this to another line. So if you're using VI, then do YY and then P. So YY is yank, P is paste or print. You do that. And then you can just modify this. So you can just say log of VID branch. I don't have to do the square root and all that anymore. I just want to see the branch current, log of the branch current, the IDS, and I'll just comment this one. Okay, so add this plot statement. You don't have to do copy paste. You can just type this as well. So do plot log of, within bracket, VID hash branch versus VD. Okay, everyone has the log one. Let's go and execute it. So do source. Okay, so now you can see, because it's a log plot, so on the left hand side it is decades now of change. So you can see now on the slope. The slope of this line is much higher compared to the saturation line. And you can see that as the temperature is increasing, the slope is decreasing. So the gain of the transistor is decreasing, but absolute current is increasing. So this is your subthreshold region here. So if you remember, so this region is your subthreshold region or weak inversion region, where the current IDS is given as some IS times e to the power VGS minus VT, some V offset divided by some era times kappa T. So in case of a BJT, it's VB over KT. Here you have this term which I explained to you how it came from the voltage division from C aux and C depletion. And this is obviously proportional to W over, W over L times the mobility and so on. And this is the one which is, so IS at 100 degree centigrade is still lower than IS of 0 degree C, but the gain, you can see the slope. Okay, this is, let's call the gain. The gain at actually 0, I'm sorry, I did the other way around. So IS at 100 is less than IS at 0. So the saturation current is lower. So basically, if you look at these currents, they go lower and sorry, I had it right the last time. Higher temperature, higher IS current. Okay, unlike the saturation current in saturation region, this current actually increases with higher temperature. So this is T100, this is T0. But you can see the slope over here is higher than the slope at T100. So the gain definitely reduces, which makes sense. But the absolute current actually decreases. Increases. Okay. Any questions on this? So basically, this is all what we sort of predicted in our session in the morning, and we're just sort of verifying it. So basically, we said the mu decreases with higher temperature. So we saw that because the slope is decreasing, and we'll when we do the Python script now, we'll calculate it and see it as well. And then the VT decreases with higher temperature. We saw that the intercept was at a lower voltage. The subthreshold current we saw is increasing with higher temperature, like we see here, but the slope is decreasing, that like we predicted. Okay. Any questions so far? Everyone, at least those who are following the lab, they're able to get the plot. Anyone stuck? Any doubts? Please raise your hand before we move to the Python one. Okay, no doubts. How many of you got the plots? Just raise your hand. Okay, good. Bunch of. All right. For people who are falling back, obviously you can just watch the recording, but try to follow as much. We are going at a very slow speed, so try to follow as much as you can. Okay. So now we're going to exit the command line one. I mean the interactive one, ngSpice. Before we get to the, yeah, we have the temperature curves here. So yeah, before we go to the Python one, let's remove the temperature curve here. We'll keep it simple because it gets a little involved when you start doing multiple arrays and all that. So we'll keep it simple. So let's remove the temperature line and we'll just do one VDS slope for different temperatures. So we'll keep the temperature at 27 now. And okay, so we are going to do the extraction for this netlist here for the Python. So just remove the temperature, save it, and you can quit right now. And for the Python 1, actually Mike has the code written such a way that you can actually run the ngSpice simulation from the Python, but we are not using CppSim right now. So he has his own tool called CppSim and everything happens through CppSim. So we'll not run it from Python. We'll actually run the ngSpice, create the data, and then we'll read it in Python and do all the post-processing. That's the way we're going to do it. And now the way we have been doing so far, we have been doing it what's called the ngSpice Interactive, right? So in ngSpice Interactive, everything is in the RAM. Nothing gets written to the disk. So when you're running the simulation, all the plots and all the data is in the RAM. When you say plot this, plot that, it just takes it from the RAM and reads it. So that's why when I do ls, I don't see any file. I just see a log file. Other than that, there is no other file. So there is the netlist. That's it. But for the Python to read that file, we need to run it in a batch mode and create a output file with all the voltages, currents, and everything of the same netlist. So for that, we'll run ngSpice in what's called the batch mode. So, you can follow me or you can go to the GitHub page. So there is, if you go to the ngSpice section here and the quick start, here I have a command here which shows you how to run it in batch mode. So it's basically ngSpice -b as in batch mode. And then -r tells you create a raw file. So that raw file is a binary file which has all the simulation data in it. And then -o is the output log file. Give some file name .log, and then give your input.sc. So this one will process it, but it will not run the script. You know how you ran the script? That script is only for interactive mode. So that script will be skipped, but everything else will run and all the outputs and everything will be saved like before. Okay, so let's go back to our terminal here. So we're going to run ngSpice -b as in batch mode space -r for creating a raw file, and we'll name it the same name. So we'll say extract, sorry, not extract, but VGS ID, and we'll name the file raw. Okay, don't make it .sp because it will overwrite it and your netlist will be gone. So make it .raw, and then -o, some log file. You can just name it output.log, and then give the input file, which is vgs id.sp. Okay, so ngSpice space -b as in batch mode -r and the file name. So what raw file name you name? So I give the same file name, but instead of .sp, you write .raw. Don't write .sp, otherwise it'll overwrite it and you have to copy again from the Git repo. Then -o output.log, and then the netlist file name, and then hit enter. Once you hit enter, it went through. Obviously, this is just the preamble. It says started batch mode. Simulation output goes to the raw file. So it says the simulation output is in this raw file. Comments and warnings go to the output log. So if you had any error, it will go here. We'll just assume that there is no error, but you can always look in the log file to see. So there's same warning, data, so many seconds. Okay, so looks like it executed properly. If you don't give the log file, it'll just put it in your screen. the advantage of log file, if something went wrong, you can go back and check the log file. Okay, so now we have the raw file, and this is a file which that Python API can read and extract all the data. Okay, so now let's open the Python script, which, like I said, I have written already, and I'll just go through it. And once we do the VT extraction, then maybe I can ask you to do the KP extraction, which is basically mu(n) times Cox. By the way, Cox doesn't change a whole lot with temperature because that's the thickness of the oxide. So the thickness is fixed, right? It'll change with process though, but it will not change with temperature. So when we extract Kp, we are essentially extracting, I mean, Kp variation with mu temperature, we are actually looking at mu variation with temperature because the Cox part just remains constant. Okay, now everyone open the Python file either in LeafPad or Vim. Everyone has it open? Anyone having problem opening the Python file? Okay, good. So, so I'll go through. So like I said, I created this example file. Now you can take this file. It has pretty much all you need for, packages wise and all that. So you can take this and then add all sorts of, goodies you want, like you want to do any kind of automation. So this will hopefully give you an idea of like the power of automation, how you can do this automation process, because especially in digital VLSI, everything is tool based because the databases are so huge, everything has to be automated. So if you get into digital VLSI, most of the time you'll be doing a lot of automation. So this will give you a feel for it. And you can, and Python is free, ngSpice is free. You can just continue doing this even after the course. Okay, so I'll go line by line, just explain you what each one of them are. And most of them you don't have to touch it. It's only the calculation parts is what you have to change depending on what you're trying to do. So the first line here says, it's an optional line, but see, I always write Python as a self-executing script. So that way I can execute it directly on a command line rather than executing on a Python shell. Like ngSpice has a cell where you're sourcing it. So actually open another cell. So let's call this Python tabs. Open another tab. We'll actually open so that we can test each of these commands. So name, we'll call it Python. Okay. So open another tab, and if you already have it open, and just type Python here. Okay. If you just type Python, it'll come up with this command prompt. So now you're in a shell. So this is the shell, which is a Python shell. Now your commands have to be all Python commands now. You cannot execute any of the bash commands we were doing before. So typically when I'm writing a script, like a Python script like this, I'll always have a shell open like this so that I can quickly test commands. Okay. In fact, what I do is I go line by line like this, testing it on the Python, so that way I know I'm not making any mistake. So actually, maybe we'll do that right now, but we have some functions and all that, so it might be better to just execute it directly. So so the first line is basically saying that if this was a script, self-executing script, what is the program it is going to look for to execute this in? Because Python is an interpreter, right? The script is interpreter in the sense that it needs a program to interpret each line. Unlike C, right? In C, where you write a program and then you compile it. Once you've compiled it, then you can execute it in a system where it was compiled for without a C compiler on it, right? because once you compile it, it's what's called a binary format, right? If it is a Linux, it's a Linux 32 ELF format or whatever it is, or a 64-bit ELF format. So it becomes executable. Python is a interpreter. So you write a script like you do for ngSpice or Tickle or anything like that. So you write a line by line code. So each line is executed serially like this over here. Okay. So the first line is basically telling you, and typically here people just put the path for Python. So like, for example, let's say the path for Python was user bin Python. Then you would put /bang/user/bin/Python. Okay, but this is a much cleaner way to put it. So what it is env is a command which is there in most Linux and Unix environment, which basically searches for Python. It doesn't assume that it is in user bin, because sometimes some installation might have it in user s bin, some might have it in user local bin. So doing this, it will be independent of the installation. So it will automatically find out if Python is installed, where it is, and it will put that path and execute Python and then start interpreting each line. Okay. And so the first couple of lines are what's called importing some of the packages. So Python is an open source tool and it has exploded. Now it's the #1 programming language, right? Every year it comes up as a programming language. And because it's open source and #1, there are like Python packages for everything. And packages are basically Python programs somebody has written to uh, expedite or make certain functions easier. So instead of you writing everything in baseline Python code, you can import these packages, like we'll see how we're using these packages before, to just use those functions instead of writing everything in Python, because that would be laborious and time consuming. So the first two are related to system and OS. So if you're doing like getting environment variables or paths in the system and so, things like that, these are the two packages you mostly use, and I'll show you where it's being used. Then this package Numpy is the most popular package for doing any computation. So this is the numerical Python package. And in Python, this is object-oriented language. So when you import a certain package, if you want to use any of the functions, you use the function as an object for that package. Okay, if you're not used to the OOP programming, the object-oriented programming, don't worry. Even I don't do object-oriented programming, but this is a simple thing of object-oriented programming, which I'll show you when we start using those functions. But so essentially, what you have to do is every function you type, you have to say numpy dot sine, numpy dot cosine, numpy dot square root. So that's why Python allows you to rename a package when you load it. So typically for numpy, people use np. So if you go and find codes in the internet, almost all codes will have numpy as np. So what you're saying is import this package, but as np instead of numpy. So instead of typing numpy all the time, I'll just type np. So it's a shorter form of numpy, because some of the packages are really long, like matplotlib pylab, right? Which is the next one. So pylab is actually a plot function. It's a package with a lot of, humongous amount of plotting and data analysis functions. So people who are doing data science, they use this a lot. If you're used to the programming language R, it has a lot of those functionalities built into it. So here also you're saying same thing. Here you see it's a different style. Here I say from pylab import star. That means import all the functions. And typically I don't do this, but I've done this to just show you as another option, because then you use the functions as it is. So for example, pylab has a function called plot. So instead of typing pylab.plot, you just say plot. That's it. But the thing is that if some other package has the same function plot, then there will be a class, and that's why I always try to avoid it. But you can use this if you know what you're doing. Okay. This is just a variable. I call a variable called ngSpice raw file and assign this string. And you remember we just executed ngSpice in the command line. We created a .raw file called ngspiceid.trem. So hopefully, if you don't have a mistake in this name, then hopefully that will be the case. The next couple of commands are basically trying to find where the Python package for ngSpice is. This is in the cppsim, installation location. This is the Mike's cppsim location. So it's basically telling, it's just trying to find it automatically. There is actually if then else statement. So you can find a little bit about the Python package also on, if you go to su2, why don't I show it to you right now? If you go to the schematic editor, tomorrow's lab will use the schematic editor more. I'll show you some. So here in the doc file, if you go to the primer, ngSpice with CPP, we are not using CPP sim, but I haven't updated the documents yet. So if you go to this file in, I think it's page 38, or if you go to the table of content, you'll see. I think it's page 38 or 36 where it starts. So yeah, so I think 35, 36 somewhere here. So if you go to the table of content, you'll see. So it gives you a rundown on how to write the script. So it's basically what we have done so far. It tells you how to run it, but you can't run it because CPP sim is not there. But now this is CPP sim view. That was here, 956. Okay, let me just give me a second here. So if you go to the table content on that primer file, you'll see yeah, you can see using Python with ngSpice. So it's 31, page 31. Yeah, so you can see it's showing you how to do it. So this system function here, he has a big if else statement to kind of automate some stuff. I've kind of wrote it in one line here, but it gives you the basic operations and so on. Okay, it's very slow for me right now, but yeah, you can go to the manual and check some of the basic functionalities of ngSpice, ngSpice Python functionality. Okay, so this essentially what it's doing is, you can see we imported the package OS. The OS has this function called get-env. It's basically get environment variable. So it's basically saying from the shell, which is running this program, get the environment variable CPP shared home. You remember in your .bash RC, you have set an environment variable called CPP shared home, which has home, like in my case, it'll be home servers, SI3121, CPP sim shared, and so on tools. So it'll automatically grab that. And then what it does, it says sys.path.append. You remember sys is this package called sys here. And sys has two overload functions called path, and path has overload function called append. It's basically saying that whatever path is there, path is, you're typing magic, you're typing netgen, you're typing su2. That's because you have already set the path in your .bash RC file, right? So here you're doing it from the Python program itself. So you're setting the path to that Python library. So CPP sims shared home / Python has all the Python packages. So once you set that, and then you do from ngSpice data import star, this is the Python package, which is written by Mike in CPP sim. And basically you're saying import all the functions. Okay. So once you're done this, then you pretty much have all the functions you need right now to read from a ngSpice file and use all the packages. Okay. Let's keep the functions for now. I have these two functions. for doing slope calculation and all that. So let's skip this for now. So let's go to the data reading. Okay. So after that, once you've loaded the package, what you need to do is you need to load the data. Okay. And that data and this is a variable name, so you can name it anything you want. I call it data. And this is the function in the ngSpice data, which is called ngSpice data. It is case sensitive, so you have to write it this way. And then this is the string which holds the raw file name. So if you want to change the file name, you can give directly the file name here, but I like it keeping it there because if you're using it in the multiple places, then you can change it in one place and it'll change everywhere else, right? So you can, sorry. Okay. So yeah, so this will read all the data which is there in this raw file. So all the voltages, currents, and everything you have saved, it is going to be read into this data as a uh, database format, which is internal to this code, right? To the code which Mike Pero Sim has written it, but he has some functions to kind of tell you what those data is and what how to find signal names and all that. So the first thing which is useful is to list the signals which is there in the data. So once you read the data, now this data is again an object oriented data. You can see now if you type data dot lssig, lssig is the overloaded function of data, so it will tell you what all the available signals are. Okay, so if I do print is a Python command. If I do print data.lssig, and data.lssig is basically the data which is coming from your ngSpice data, it'll print all the signal names. When I execute this, I'll show you. And so once you know the signal names, what you can do is you can start reading them into each one of them into the array. Like for example, I want to read the drain current first. So I call a variable called ID1, for example, here, and you use a function called evalsig. This is the function in ngSpice data. So you use it called data.evalsig, and this is the signal name which you will find from this command, and I'll show you when I execute it. And so this is the signal name. So you give it as a string. So use their data.evalsig, give it as a string name, I underscore vid1. And then I want to read the voltage. So voltage is actually, it's a keyword voltage. So for example, in transient, it will be keyword time. And again, it'll actually appear in this lssig signal. So you read the voltage. So now you have the voltage, now you have the current, and you want to plot them now, right? So, so forget the KP VT calculation right now. First, we'll just plot it. In order to plot it, this is the setup procedure. You just take it, there is a lot of different ways to use PyLab to plot it. This is like a standard method to do it. So first what you do is you open a figure called figure 1. Figure is a function in PyLab. So if I didn't write import PyLab from PyLab import star, if I just did import PyLab, this should have been pylab.figure, right? And then fig.clf is basically saying, so once you assign the figure to fig, fig is an object. It's a figure object. And this object has many overload function. And this is all there in the matplotlib manual. So you just go on the web and say PyLab, okay, Python PyLab user manual. And there's like more information than you ever want to know. So all you do is you just go and you type okay, so looks like my internet connection is a little bit unstable. Can you guys hear me fine? Sandhanu, am I audible fine?
Audio is fine, but that's sometimes this is
It just lags basically sometimes.
yeah, but audio is fine.
Okay. Yeah, I think my system is a little bit slow. I mean, my broadband is a little bit slow right now. Gets okay. Just if you have any issues, just raise your hand. So what I do is I want to plot root ID. So I plot root ID. Uh, I find so square root is there is no square root in raw Python. You have to import a package. So there is a package called math actually. You can import that, but Numpy is more popular because it has a lot more other functions too. So you can see I imported Numpy as import Numpy. If you remember, I did. So it looks like I stopped sharing. Just yeah. So if you remember, I did import Numpy as NP. So that's why all the functions start with NP. So np.square root is a function from the NumPy package. Okay, and then okay, and then I plot it. So plot is a function from Pylab. Again, if I didn't do from Pylab import star, if I just did import Pylab, then this should have been pylab.plot. So plot V, so you basically give X and Y, and obviously I've multiplied it in 1E3 just to give everything in milliamps. And you give your X label, Y label, give your title, grid, and grid again. And all of these functions have a lot of options. So for example, you can see grid has a function, and here I'm giving option both in the sense that I want grids both on the X axis and Y axis. And then you give basically figure is the object. You just do figure.show and it'll show. But so I'm going to show you two ways of executing this. So first way, what I'm going to do is, so this is hopefully complete, and I'm going to execute now. You can type Python and give the script name.
Sir?
So what is this? Yes.
Sir, we have to edit that figure.show.
Yes, just uncomment it.
Okay.
Yeah, just uncomment it now. So that way we'll just do the plot first. Okay, then we'll do the calculations. So let's do the plot first. So now you can just type Python and extract oh, that's because okay. Yeah, I just changed these values to okay. So just comment this line as well. The VT KP, comment this and the print statement after that. Just comment these two lines as well. We'll execute that function after this. Okay, so you see there is no plot which came up. That's because we are not in the interactive mode. So because it is executing line by line, it actually brought the plot up, but it just went away. You just didn't see it, right? So there are a couple of ways to kind of hold the plot. One is you actually execute the script from the interactive mode. So you can type Python -I, okay, and type extract vt stas kp.py. If you do this, it'll go into the interactive mode. If it goes into the interactive mode, it actually holds the plot because it's just going one by one line, and the Python shell is still available. You can see the Python shell is still available, right? So I did Python -I extract.py and do it. But there's no good way to actually read the Python script from the shell, which sounds crazy, but some of the quirks in Python are just, sometimes it just I just scratch my head.
Sir, can you please tell which line to comment?
Yeah, 1 second. Let me exit here. can see it doesn't take exit, it needs the, so vim extract. So if you go to line number, set your line number, you go to line number 53, 54. So you see where it's written calculate VT. Okay, and I have, so I just put it 0 because I wanted you to give guys to give values, but the function is actually complaining because it's doing a divide by 0. So just comment these two lines basically. Okay, and then uncomment this line fig.show because we want to actually show the figure. Everyone got this? I'll just wait for a few seconds here. Everyone's good? Anyone wants me to wait, just raise your hand. Okay, go ahead, Sumant.
No, sir, I'm doing just a minute. Sir, after this, we will write Python space -i.
Yes, -i script. So what I'm going to do is I'm going to leave this exec. I'll go to the Python maybe, because I have another one. I'm going to exit this shell here. So I'll do Python -i and extract. So you can see it came into the interaction mode and did the plot. So you can see it did the square root I. So this is exactly what we got from our spice file, right? And you can see the first command was doing a list of all the signals available. So that's the output here. You can see. And ignore that U dot. That's just a Python database thing. So all the signals are whatever is included in the codes. So this D1, B, D, IVSB, IVD1, IVDS. So these are the currents and voltages you can basically load and do operations on, plot or do any calculations on and so on. Okay, so while some of you are still doing it, so I'll show you a couple of other ways to execute this. So you can hold the plot also by so you see I have another line here at the very end, uncomment that as well. It's saying input, basically press any key. So this will actually wait for you to press a key. It's like, you know, see, you have fscanf. So this is like fscanf basically. It's just going to wait for you to press the key. If you do this, then you don't need to go into the interactive mode. So what will happen is now if I go back and if I just type Python and just type the script name and it'll execute it. Now you can see before it came out, because it executed, the plot came, but it is waiting for me to press any key, right? So till I press that key, it's just going to hold the plot. So you can verify whatever you're seeing. And then once you hit the plot, I mean, hit the keys, I don't know why this error is coming for string line, blah, blah. Yeah, don't worry about the error. I think there's probably some error with the argument or anything like that. But now you're back in the shell, right? I like this way because, you know, when I write a script and it is a self-executable script, I don't want to be going to the Python shell all the time and coming back, right? I just want to execute it as the program, like I do for ngSpice or any program like that. Okay, so you can insert that input here. So when you have a plot, you can insert that to hold the plot. And then that way, it'll just show you and wait for you to press the key. When you press the key, then it'll end the program and it'll obviously kill the plotting window and it'll be back. Another way is actually you can save the plot as a PNG file or something else. And there's a lot of methods in PyLabs to do that. You can look in the web on the matplotlib and the PyLab user manual. So that way, what you can do is you can just execute the script and you'll just have a new PNG file and you can open the PNG file and just look at it. But obviously, if you're doing a lot of debugging, when you're running things in batch mode, I like doing directly to PNG files because if I'm generating 100 plots, for example, I don't want to go through 100 plots. I just want to generate them and then put them in my PowerPoint or whatever slides, right? So you can just execute, you can save it into a PNG file as well. And that's part of the PyLab function as well. Okay, so this is one way. Now I'm going to show you, now you have to get out of the editor. So just come out of the editor for a little while. Now what I want to do, which
Excuse me, sir.
Yes.
Sir, in that means I'm not getting that plot in that Python hyphen I and extract the file name.
No, you're not getting in. Tell me exactly where you are getting stuck.
Means when Python then extract vtkp dot py, then I'm getting that output here, but in that Python space hyphen minus hyphen I, then the file name, but you're getting a plot, right? And
what are you getting? Are you getting error or you're getting a
no,
plot?
no,
Or
no,
you're
I'm
getting
not
another
getting
plot?
a plot. No. Everything means I'm getting that thing, but not getting a plot. That plot
Did
I'm
you
not getting.
uncomment fig.show?
Sorry, sir.
Did you uncomment the line which has fig.show?
Yes, sir. Yes, sir. Uncommented. Yes, sir.
So what's your problem? I don't know. I just send a screenshot.
Okay, sir.
Yeah, send a screenshot. Then I'll I'll just
Yes,
keep
sir.
going.
Yes, sir.
Yeah.
Yes, sir. Yes, sir.
Okay. So I showed you that you can start it in interactive mode, but each time if you have to come out, then you have to come out because there's no good way to load the script. There is method, but it's not clean. Like like in ngSpice, you do source file name and you read it, right? Unfortunately, Python doesn't. At least I don't know of any clean way to source your scripts. And Python is usually meant to execute it as standalone scripts. So you can make this as a standalone script as well. So you remember I said if you look at the very top of your Python file, this line we added over here, that allows you to actually make it an executable script, because then it'll, when I make it an executable script, it'll read this line and try to figure out what program I'm trying to use to run this program. And from there it'll, yeah, Brathiranjan, you don't have the fig.show uncommented. That's why you're getting this. Okay, just uncomment that
Sir,
and run it.
in that file I uncommented it, but it's not showing.
Yeah,
Let me check again, sir.
Yeah,
Yes, sir.
just
Let me
check.
check again. Yes.
Yeah, I think you just haven't uncommented it. Okay, so you can see, because I gave this line here, I can make it an executable. Now, if you remember the very first one, when I introduced you to Linux, you did a ls -al, let's say, it shows you all the permissions, right? So these are just normal files right now. So for example, extract.py, just a normal file. And I cannot run this file as a shell command yet as executable, because I need to give it a, like for example, you have an X here, you need an X here for it to be able to execute it. Okay. And in Linux or Unix, the best way to do it, so you can do ch mode and then give the proper mode like 6755 and so on. But they have overload functions in ch mode as well. So what you can do is you can just say ch mode plus x and then say extract dot py. Okay, and then if you do ls minus al now, you'll see that its color is green now, because in ls colors minus minus colors all executables come as green, because now you see there is a x for all users, groups, and everything. Okay, so this way I can just type it. I don't have to write Python or anything like that. I can just type extract dash vt dash kp.py right here, and it will execute it. Okay, but before I do that, because this directory is not in the path, so what I have to do is I have to say dot slash extract p.py, and if we press enter, then you'll see that I still get that output like before. I get the plot. It says press any key to quit. I can press a key and quit. So I didn't have to type any Python or anything like that. I just executed the function directly in the bash prompt like ngspice and all that. Just that ngspice is in the path. Because my library is not in the path, I mean my directory is not in the path, I have to give this dot slash in the beginning, because dot is basically saying that it is the present directory. In the present directory, find this program and execute it. And when I do that, then it executes the script. So Pratiranjan, were you able to see the plot now or not?
Yes, sir. Yes, sir. Now I got it. So
Okay.
it was again commented. That's why it's not showing.
Sir,
Yeah,
can you please tell again what was the difference between the previous graph and this graph?
there is no difference in the graph. I'm just showing you different ways to execute the Python script. So first I showed you how if you execute it as Python minus I, that will open the Python in interactive mode and load the script and execute it. Second, I showed you just type Python script, but it will execute it and come out. If you don't have this press any key, then what will happen is you will not see the plot, because it plotted it and it came out, you just didn't see it. And the third way is I'm saying you convert that script into a executable by typing this command chmod plus x, the file name. I've already obviously done it. Once you do it, it will actually become executable. And now, because I have the first line in this script is this line here. If I make it executable, if I just, and making it executable in Linux is very simple. I just put X and then Linux will try to execute it as a binary. But the thing is that if I didn't have this line, what it will do is it'll execute all this as bash commands like ls, pwd, cd and all that. It'll try to, and it'll say this command not found, this command not found, this command not found, and so on, right? But because I have this is a class, I mean a standard way in Linux where it, when I have a hash bang, it basically tells you what kind of script this is or what kind of program this is, and then it knows what program to use to do this. So like for example, if you have a bash shell script, usually you'll have hash bang user bin bash or user bin sh or user bin csh and so on. Okay, so basically I'm just showing you different ways how to execute this Python script, and I'm just telling you that my preferred way is converting this executable and typing it. So now you can open the extract.v and make any changes here, and you go to your Python shell and just type /extract.vy and it will execute it. Okay, so you don't have to keep typing Python minus I or go into the command prompt, I mean interactive mode and so on. Okay.
Yes, sir.
Is everyone following here? Well, let me do this. Let me give you like maybe 5 to 10, let's say 10 minutes. Let's take 10 minutes, not break. I'm going to be here. And those of you who are trying to catch up, take this 10 minutes and try to catch up. Okay. And if you have any questions, just let me know and I'll answer. So so I'll give you 10 minutes for people who want to catch up. And so basically, like I said, you open the script, right? Open in VI or leaf package, whichever is your thing. and then you don't have to type anything. I just explained all the thing. You just uncomment this line here, which says VT dash KP equals to VT KP. This is the function I have for calculating VT and KP. So we'll do that next. So just uncomment that because I put some zero values and it is complaining. And then uncomment this, remove that hash from fig.show. Otherwise, when you execute it, it'll just list all the signals and not show you any plot. And uncomment this as well so that it'll wait. And you can, like I said, you can just type Python script name after you give this input, or convert it into a script like I showed you, executable script by doing chmod +x, the file name, and then to execute the Python script, the executable one, you just say // the name of the script and hit enter, and it'll execute the Python script. Okay. So I'll wait for 10 minutes so let people catch up.
So,
Yep.
so I'm not getting the last line that input you are just defining, right? With the input command, we are just assigning any string value to that any for. If we will write something like a equals to input, then it will assign a to that string, whatever we are going to type.
Okay.
So
Yeah. So input actually, yes, you're right. So if I have to be exactly correct, so I can do str is some variable equals to input. Okay.
yeah,
And then I
Yes, sir.
can say print str, right? But my purpose is not to grab anything. My purpose is to just make it wait. Okay. Because I'm executing it in the command line, it is finishing everything and coming out before I can see my plot. And I don't want to go into the interactive mode. So that's why I just put this in.
all right.
You got
So
it, right?
we also can use like time dot like just to wait.
No, but then, time, I don't want to wait for a particular time either, right? I might be watching the plot for 2 seconds, 2 minutes, 4 minutes, 1 hour. What time are you going to put?
Yeah, there is also a command like that. Close all window that zero something.
See, for this, there are 3,000 different ways to solve this problem, right? I'm just showing you one way. Do you have a problem with this, or you don't like it, or what is the problem with this?
No, I couldn't. Actually, I couldn't understand that what you are actually doing with that input alone. Over there.
So like I said, I'm just waiting for a key press,
Yeah,
right?
yeah, I got that.
Yeah. Yeah, there are a ton of other ways to do this. But I mean, not ton of ways, but there are various other ways. But this is like the simplest way. Yeah, I'm getting an error. I don't know what that error is, but it seems like it's something to do with. Actually, now that I've assigned it, let me execute it and see if that goes away. File string line 0 syntax error. Unexpected end of line. Yeah, I have to look at the manual for input. I think maybe maybe there's some mistake. Oh, actually, did it print? Yeah, not sure why it's complaining.
Sir, hello.
Yes.
Sir, in the last line, we can like convert it into if length input and input. In case of input, whatever that statement is written, like press any key to quit, that remain as it is, and we will give an if statement. If its length is greater than 1, then it will directly quit. The this command can, like, without showing
What are you
any,
trying to do?
just quitting without. Right now we are getting the error. We can directly exit that code without any error.
So what is the error, by the way? What is the error?
Actually, we are just giving an unnecessary, like, if you are not assigning any statement or any value to that, to any variable, it is just throwing. We are like just giving.
No, I
And
gave the variable because you complained about it. I didn't want to give a variable name. I just had an input for key press to wait. I don't know why you're hung up with it. How are you going to make the plot wait?
no, sir, actually, that is okay. But after that, when we are giving that only input that press any key, so instead of that, we can make it into a complete code, and we can directly exit from that code.
No, but it is the end of the line. You don't have to do exit in Python. These are interpreter. It's not like you don't have to exit. If there is nothing, it just overs, that's it, right? I mean, when we didn't have input, when we exited, we didn't have exit code, right? That is only if you're doing a if and else to exit it. Why you want to put a if? See, you are blaming me for putting unnecessary code. Why are you putting a if else statement? What is the if else statement for? Don't worry about it. It's something to do with just the input. Don't worry about it. It might be to do with Python 2 instead of Python 3 or something like that. Don't waste your energy on this one.
Okay, sir.
Okay.
Yes, sir.
Don't get hung up on that. We're just trying to wait on it so that we can press a key and exit so that the plot doesn't disappear right away, right? That's the only thing. And this whole thing I added because you just didn't like the fact that there was just an input. Because this is the simplest way to wait for it, right? What you're saying is adding more complexity. Okay, I think 10 minutes almost up. Anybody still wants me to wait so that they can make those changes? How many of you are getting the plot? Just raise your hand from the Python. Okay, good. Just 5? What about, okay, but then, what about the rest? Why are you guys not trying? Okay, let's proceed to the next one. Hopefully, maybe that will give you a little bit more motivation to do it. So we plotted it, we've seen it. Now what we want to do is we want to extract the VT and the KP values from the slope, right? So you remember how we did the VT calculation, right? So for the VT, we did, so this was our VGS and this was root 2ID plot, right? And so for VT, we said, we took the slope here and we linearize this equals to y equals to mx plus c. And then using this equation, we actually found this intercept and that was our VT. and then the slope is Kp is equal to slope square times L over W, right? So these are the two things. So now what we're going to do is we're going to automate this, but we have to help. I mean, this is not going to be a super duper script. It's still going to need some help from the user. So what we are going to do is we are going to help the script a little bit. So I've written, so what I've done is, okay, so let's forget the plot now. We're going to trust the plot for now. So I'm going to comment the plot back again, and I don't want to wait for the input anymore. So just comment this line, fig.show, and input press any key. You can comment that now back again. So that way I'm not getting. And then uncomment these two lines here. So I'll just go through the code, and I have done VT, and I'll ask you to do the slope. So basically what I've done is I've written this function, right? It's called VTKP, where I send the entire voltage, right? So it's a array, because the voltage is now an array of signals. So you know how we step through, right? Point B equals to 0.1 to 2 to 0.001. So it's about 2000 to 4000 points. So you have an array size of 2000 or whatever, 4000 points. And same thing with ID1. And then I'm going to give it a value, V1 and V2, which it is going to use to calculate the slope, right? So for example, here, okay, so let's do the plot again, just 1 second. So that way we can choose that value again. So let me uncomment this back again. Okay, save it. And if I go here, I think I've forgotten to, oh yeah, fig.show. All right. So let's say I want to choose the value. Oh, actually, you know what? We're going to use, let's use the numbers we used last time, right? So you remember we created a worksheet, right? So let's see, which was it? Lab 2, I think. Yeah, we have a worksheet here. You remember the last lab we created a worksheet? Okay, there it is. So when we did our hand calculation, so write this down and we'll just compare it and see if we're getting this. So we chose V1 as 0.754, V2 is equal to 0.995, which we can just write 1. And we got VT equals to 0.512. And we got Kp equals to 122.31 microamp per volt square. Okay. So let's have these numbers. And so we are going to use the program now to do the same calculation, see if it is close to what we calculated or it is something very different. Okay, so in this function here, so I'm giving this value V1, V2, and we said we're going to choose V1 as 0.75, right, 54, and then V2 as 0.995. And then W over L, we are simulating for 5. So I'll just write 5.0. Okay. And then let's execute this. I don't want to see the plot now, so I'll just remove the plot for now. Let's execute this and see what we get. VT, we are getting 0.51, which is close. KP is 0. Oh yeah, because I'm doing ampere, but I'm doing only percentage 32F. So let's make it 0.3. Let's make this 8 decimal points. Hmm. 0.51. Just give me a second here. Oh, actually, I've asked you to calculate. Okay, so this is actually for you guys to calculate. That's why it's coming out to be 0. I'll keep this one E6. Make this microamps. Okay, so like I've shown here, so VT is 0.512. So the calculation has come out to be 0.512, which is what we got when we did the hand calculation. In fact, we got exactly the same number. So which is, but now we had calculated the slope by hand by doing this cursor. So obviously that could be a small error, but looks like we were very close to it. So the KP, I will ask you to calculate it. Let me go through the code first, show you, and then we can do that. All right. So this is the main function. So where I'm passing the voltage vector or the voltage array, the current array, not the root, but just the current array, which I read from the spice file, right? So from the spice file here, you can see ID1, I read it as ID1, V as V. So I'm passing it as it is. So that way I can do whatever calculations I want inside. So I'm passing that. And I'm also expecting that V1, V2 to use those 2 points to do calculation. And what is the W over L? Because I need that to extract the KP, mu and Cox. So I need that. So I'm done that, right? Now to do VT, what I'm doing is first I'm taking the root of 2 times ID. So NP times dot square root 2 times ID. And I have written another function called slope where I pass the voltage, the root ID, and the 2 points I want to calculate the slope. And if you go to the top, you'll see, so I'm written this function slope, which basically all it is I've given the X vector, the Y vector, and I've given 2 points X1, Y2, and I need to find Y1 and Y2. The way I find out Y1 and Y2 is I use this function from Numpy called np.where. So essentially, I'm trying to find out what is the index of X1. I take that index and assign Y to Y1. So Y of that index to Y1. Then I find out what is the index of X2, because these vectors are one-on-one, right? So V of 0 and ID of 0, V of 1, ID of 1, they're one-to-one. They're the same length vector. So I can do this. So then I find the index of X2, find Y2, and then I return Y1, Y2, and the slope, which is Y2 minus Y1 divided by X2 minus X1. So it's pretty simple calculation, right? And so I get the slope and the ID1, root ID1 and root ID2, and the slope from this function. And then you remember how we did the hand calculation? We first found out C, right? We found for this y equals to mx plus c. So this one, this y equals to mx plus c. First we calculated c, which is my y minus mx, right? So that's what I'm doing here, right here. So this is y here, and this is m times x. And then once I found c, then from this equation here, vt is this line when it is intercepting x-axis where y is equal to 0, right? And so at y equals to 0, x is equal to minus c over m, right? And that's nothing but that's your vt. And that's what I'm doing here basically. Vt equals to minus c over m. Clear? And that seems to work fine. Okay, now I need you guys to calculate Kp, right? You remember Kp, it's a very simple equation. So why don't you go ahead, do Kp and execute the program and see if you're getting 120, what did we say, 122.34, or it'll be close to that because we manually calculated the slope. So just try to get there. So calculate Kp in this function, and then obviously the place where I'm calling the function, if you have done it right, then it's going to return the right value. And you should get the right value after that. Okay, so where I have written fix me, basically write here Kp, write the expression for Kp, and that will complete both the Vt and Kp. And then we can try out different temperatures and see uh, what we saw on the plot, it's being extracted right or not.
Hello.
Yes, hi Ashwin, what's up?
So how to write the square expression?
Okay, good question. So in Python, the power function is star star. So if I want to write x square, you write x star star 2. Okay.
Okay. Okay.
Sir, we can write x
So
star x also,
multiplication.
right?
Yeah, you can write, what is that? X times x. Yes, you can write x times x as well. And there is
So
a power
multiplication
function
is
in
same.
Numpy as well. But yeah, typically in Python, we use star star square, but that's more efficient than doing xx. So, but yeah, this is a small program. We don't have to worry about efficiency. Yeah, go ahead, Ashwin. What is your question?
So multiplication sign is single star.
Yeah, multiplication is
Okay.
star. You can
Okay.
see all these places, right? I've used star.
Okay. Okay.
Those who are done and get an answer, they can raise their hand. At least I know.
Hello.
Yes. Yeah. Yes, Ashwini, what's
So in this code, L and W are not defined anywhere.
No, I've given you
We
W
can
over
write
L, right?
the
5. That's a parameter here, right? Which is called W over L. So you have to give this parameter while you're passing it through function. So that's available to you, W over L.
it will be inverse.
I'll do the inverse. I mean, you have Python at your disposal. You can't do because nobody gives you L over W's, right? They always then the aspect ratios are given in W over L. So wherever you need L over W, just take the inverse.
Sir, hello.
Yes. Yeah. So that's good.
Sir, in this case, our slope, we have the slope, right?
Say that again.
Sir, we have this slope, right?
Yeah.
So we can directly put that Kp equals to, we know that root over Kp W by L equals to slope.
Yeah.
So we can directly put that Kp equals to slope square L by W.
Yeah, that's what you want to do, right? How else you want to do?
So that L by W, you said something like that equal to 5
Yeah,
or something.
no, I'm saying that is passed to the function, right? If you look at here, I have passed W over L. I haven't passed W. See, nobody gives you L over W, right? They give you W
Yeah.
over L.
So 1 by over L something.
Yeah.
Yeah. Okay.
So you can.
Okay.
Yeah, that's all you have to do. So this should be quick.
Sir, there we will write slope square. Like we can write slope square.
No, you can't write. There is no variable called slope. So
Yes, sir. So in place of slope, we have to write the formula.
yeah. So what is the variable here for the slope? There's a variable which is being assigned in this. See, this is the function, right? This is the function which is returning y1, y2, and slope. Here I'm calling the function, and this is called n tuple. So you can return a series of numbers in Python. It makes it easier to do that instead of putting in, arrays and this and that. And there can be different types too. One can be a string, another one can be integer, one can be floating. So here I'm returning. So y1 is the root of id1. Root of id at v1. Second variable which is returned by the function is root of id at v2, and the third one is the slope, right? Here the slope is the function name. That's not the variable.
Okay.
So
Yes.
the Kp is coming again and again. 0 is not changing.
Have you calculated it?
So I given the formula in
How
that
have you given the
expression.
formula?
Kp. So m star star 2 divided by over L, W over L.
It is not 0 because your calculation is 0. So what is happening is